right. In this section, we're talking about rational, irrational numbers. I've mentioned about rational numbers many times. When they're rational, they can just be written into a fraction. A fraction is also a decimal, anyways. Then what is irrational number? Irrational number, first of all, is discovered in history is root of 2. And in the Western world, not in the Eastern world. In the Western world is, as a matter of fact, by record, by Pythagoras himself, because one of his very famous right triangle is this side, and then he ended up this side is root of 2. He's absolutely horrified to see, as a matter of fact, this root of 2 does not come out of the radical sign as a fraction or even a repeating decimal. It's absolutely non-repeating decimal. He never knows when this root of 2 would stop. And he never have any guess to think that what would be the next number for the next digit. This kind of uncertainty and predictability just about killed Pythagoras. Anyways, and it started being accepted, and that's just a matter of fact. So this is not too much to talk about these irrational numbers. Nobody really likes them just because they're just a wacko. They're just these non-repeating decimals goes forever. So in this case, we just have to, for irrational number, we just have to approximating, just like try to know how much is root of 2 then. Well, how much is root of 2? The way to think about it is that if you have 2 perfect square, which is 1 and 4, right? And then you have this 2 in between. So then here we go. If we give this a radical sign, we'll give this a radical sign. This end up, this one is 1, this one is 2. So this one equals this way, this one equals to this way. So then we can see, well, the root of 2, on the other hand, is somewhere in between 1 and 2. But it's much closer to root of 1 rather than to root of 4. So now from 1 to 4, how many spaces are here? There is 3 spaces, right? 4 subtract 1 is 3 spaces. And then the 2 to the 1, that's 1 space. So that means 1 over 3 is this, which is approximately 0.3 repeating. So then, okay. So then root of 2 could be approximately just 1.3 repeating. Well, then that is good enough, right? So give you another example. Now, what is the root of 7? So root of 7 here, root of 7. Then we wanted to find the perfect square, which is 4 here, which is 9 over this way. So then this is root of 4. It gives me a 2. There's a root of 9. Give me a 3. Sure. And this root of 7 is definitely somewhere in between here. Now, where it is. Now, from 4 to 9, the total space is 5. Okay. So then that is 5 at the bottom here. And now, from 7 to 4, then there's 3. So then that is 0.6. So then I'm saying, okay, well, then root of 7 could be just approximately 2.6. That's about it. Well, that's just how I estimated. Wow, then this is this one. So this is just to let you know where it is. Then we're doing whatever it says is just over here. So again is root of 11. So root of 11, I will have a 9 over here because that's a perfect square on my smaller than 11 or the closest to 11. And then I have 16 over here. And then again, this is 3. The root of 9 is 3. Square root of 16 is 4. And again, at least I know 11, root of 11, square root of 11 is between 3 and 4. Okay, 9 to 16, 7 space, the bottom here, and then here, 2. Okay, well, as a matter of fact, if I write into a fraction, my root of 11 is approximately 3 and 2 over 7. And that's my estimation. So this is just good enough. All right. Well, thank you for watching this, and do a couple of practice and use your calculator to verify. You pretty much, if as far as you can estimate to this point, you're perfectly fine here.